Uh, there we go. So welcome everyone this afternoon to this session focused really on neuroscience. We have faculty member from Boys Town, Dr. Doucet, who will present first, I think, and then followed by, and let's see, so you're at the Brain Architecture, Imaging, and Cognition Laboratory. And are you secondary faculty at Creighton now too?
Yes, exactly.
Okay, so a member of our community in Omaha now in the Department of Pharmacology and Neuroscience, I think.
Yes.
And then Dr. Brad Racette, who is Senior Vice President at Barrow Neurological Institute in Phoenix and also the academic chair for Creighton's neurology in Phoenix. And thank you both for being here. And I think I guess it's your preference, our speakers. Would you rather have questions held to the end, thrown in the chat, or we don't have a huge audience, unmuted and asked directly?
I think it can be anytime. Yeah, it might be
Okay.
easier to unmute.
Okay. How about you, Dr. Racette?
Totally flexible.
Okay. All right. Great. Well, with that, please take it away, Dr. Doucet.
Okay, let me share my screen. I hope you can all see. So I'm Gaelle Doucet. I have a PhD in cognitive neuroscience. My background is really in MRI. I study how the brain network change over the lifespan and how it is impacted by disorders such as epilepsy, schizophrenia, and more recently I started a new project about developmental language disorder. And so that's what I was hoping to talk about today. So it's really a project in progress. I have in the middle of resubmitting this grant. So all the data presented today are unpublished. And so I'm totally open for discussion and, question. If you don't get something, just let me know and I'll clarify. Developmental language disorder is a neurodevelopmental disorder that impacts language and especially obvious in children. So they will have trouble to understand, speak, or read in the absence of any other disorder such as hearing loss or autism or any other things. It's actually quite prevalent. It's about 7% of children will have DLD, diagnosed with DLD. It's as much as the ADHD, and it's 5 times more than autism. So it's actually quite common, but it's very poorly diagnosed at that stage. There is no clear approach in school to diagnose that. So it's still quite unknown. And we actually really don't know the brain mechanism behind these disorders. Everybody focus on language because obviously it's the main disorder, but as I'm going to talk about, it's not the only one. And another point is that it doesn't disappear when we grow. It's also present in adult population. And so, I'm sorry, I'm sick. This disorder, even though it's called, language disorder, it's not just about language. Those children also show significant impairment in non-linguistic domains. So they really have issue with procedural learning, executive function, attention, and so on. They also have higher risk of clinical anxiety and depression. And other social impact is that, for example, girls with DLD have 3 times more risk of being sexually abused, boys 4 times more to be engaged in delinquent behavior. And even in adult population, they are more likely to be unemployed for a long time. So it's really an issue, and it's something that should be more investigated. But so far, what we know is that So we know a lot about the behavior of those children and adults, and it's really focused on language. So we know very well the language impairment in this population. But at the brain level, we really don't know anything. There's really very few studies, and all those studies are very heterogeneous because they are based on small sample size. So we don't know really where it's coming from. And actually, the biggest study done on the language networks, that is, you probably may know, it's typically located in the left hemisphere, in the inferior frontal cortex. So it's this big yellow area, which is typically called Broca's area. And it's actually not found abnormal in those children. So it may be because the sample is too small or the task is not appropriate, but still, it's not an obvious alteration of the brain. A very recent study that was published like last week actually suggests that it's more basal ganglia. The issue is that it is commonly found as altered structurally and functionally in those children, which would be linked to procedural learning impairment. However, based on my pilot data, we found a lot of linked with executive dysfunction. And so what I'm trying to do is investigate the neural mechanism in children with DLD and link it to executive function. And for that, we have recruited children with DLD and typically developing children in Omaha. We go through a complete neuropsychological evaluation, and we do an MRI. So that's our MRI at the Institute for Human Neuroscience. And we measure the brain activity at rest and during working memory task, a language task, and we also do structural MRI. What we found at the behavioral level is what other people have found is that those children with DLD, so those are in purple, show altered cognitive function compared to children typically developing TD children. And so it's not just language measure, but also working memory measure shows alteration. So they are
Dr.
lower.
Doucet,
Sure.
so my question is, like, how do they diagnose this language disorder in children?
Yeah, so there are, I think, multiple ways. So there are specific language cognitive tests that we collect. It's a TNL, so I forgot what it is standing for, but it's like storytelling and things like that. And then based on the rate of a score at 92, under that, it means that they typically have a developmental language disorder. Above that, they are TD. But there are also a lot of speech pathologists that can diagnose that with neuropsych evaluation.
And this method of diagnosis, what is typically the false discovery rate?
What do you mean?
So I mean, so is it possible that you can misdiagnose a child that you're saying that child has this disorder, but indeed probably not?
Yeah, so it's a lot of time. I think they first start by thinking it's just dyslexia, for example. But after, like, you need a complete evaluation to really detect that. But those children will have issue with, for example, following instruction or learning new words, of expressing themselves. So at the beginning, they may just think, oh, it's just a delayed, this kid is speaking a little bit late. Actually, the earliest age of diagnosis is 5 years old. Before that, we cannot know. And so after that, it may take actually years for diagnosis. It's like ADHD. It's not diagnosed immediately. It can take years. There is also a high comorbidity with ADHD and autism. So you have to, we test for autism as well and ADHD. So to make sure those children don't have autism, they also don't have hearing loss, or any hard of hearing children will not classify as DLD. So you need to really do like multiple tests, and then there is that type of diagnosis, which can be speech impairment or DLD. Now it's a specific category.
Yeah, so typically it takes time, right? It's not like an instant.
Yeah, it depends where you are. Like, so Boys Town is a very, we have a specific center on DLD. So, for example, those people are very expert in diagnosis. diagnosing those children. And so we're running studies on this population and go to school and try to implement actually a more appropriate diagnosis tool with having same test across schools. But so far it's still quite new, and it's still not very common. So teachers don't want to start to run new tests and things like that. So it's still difficult to do because parents and teachers don't really know about this disorder as well. It's not that well known. So it takes years just because we don't have the tools to do it appropriately.
Yeah, got it. Thank you.
Yeah, of course. Yeah, and we are actually having, I know my coworker at Boys Town, it's Carla McGregor. She's a speech pathologist, an expert in the field, and she got recently grants to go to school and try to open a conversation with teacher and parents and see how we can help diagnose this disorder. It's also more common in population with lower SES. So it's something that is investigated. We don't know, again, which one is cause, which one is if it's an association or cause, but like there are multiple factors to account for. So overall, at the neuropsych evaluation, we were able to reproduce what other people have found, is that basically it's not just a language disorder, working memory is impacted as well. And when we did a brain MRI, so what we do is we collect what we call a T1, and we can measure the size, the thickness of the cortex, and the size of the different brain brain regions in the brain. And what it's quite interesting, is typically a lot of disorder will show thinner brain, right? You lose neurons, so you show a reduction in cortex, in the size of the cortex in specific disorder compared to healthy population. But in this case, all those red regions show an increase in size of the cortex. So thicker cortex was found in children with DLD compared to typically developing children. So, and all those regions, for example, here, those lateral frontal regions are all related to executive function. Mostly the frontal lobe, as you can see, is thicker in those DLD children. We also found an interesting age by group interaction where, so in theory, in normal development, you actually get thinner cortex while you get older during the adolescent stage, because there is a pruning event where you lose neuron. But actually, we could only see that in the children that are relatively healthy. The DLD children did not show this effect. And inversely, in the region that are the subcortical region of the brain, we found the inverse, which again, in theory, while you get older as a child, your brain volume will become bigger at that age range. But it was inverse in the DLD children. And I forgot to say that, we only recruited so far children that were between 7 and 13 years old. So it's really pubertal age, like developmental adolescent stage, where we know very well what the typical pattern is, and those children did not show this normal pattern, which would suggest that there is really a clear developmental impairment. So we obviously run a working memory task, so it's called an NBAC task, where children have to remember a letter that was presented either 1 back before or 2 back before. That's a very good, very well-known task to activate the working memory network. And before I present the result, the brain result, we found at the behavioral level, consistent results. So we did this task at the visual spatial level, where they had to remember actually the location of the letter or the letter itself. And so that's the same task, but that's why we can measure the verbal aspect or the visual spatial aspect. And interestingly, while the DLD children show also lower accuracy for the visual spatial task, it was not significantly different. But in the verbal condition, it was significantly lower in the DLD children. And as the tasks become more difficult, we actually found this effect increasing. So when the task is very easy, they just have to press when they see an X. They don't show any significant difference. So they can do it, right? Motor function are okay. But as soon as the tasks become a little bit more challenging, where they have to remember one letter before or two letters before, they start to show lower accuracy, while their reaction time do not change. It's not significantly different. And at the brain level, when we look at what is more activated during the more challenging task condition compared to the easy condition, we found the working memory network, which typically activate lateral prefrontal cortex and lateral parietal regions that are all involved in executive function, attentional processing, and so on. And as we found for structural result, is the DLD children show higher activation in this inferior temporal region. So all those regions, I just want to make sure that it's a very low threshold, because again, we're doing pilot study at that stage. So it's a low threshold. So I would just keep that as a cautious about interpreting, but it's still suggesting that somehow the children with DLD overactivate or have thicker regions that should not, especially because their behavior does not match the control, right? They still show lower result, lower accuracy. And actually, it was obvious, there was a group by accuracy interaction where TD children activated very typical region of attentional processing, those three regions, and more activation in those regions were associated with higher accuracy, which is totally typical. But in the children with DLD, they show the inverse profile, which is totally abnormal. I think we have time. So we did also a resting state fMRI where, so it's a now very common condition at rest. People do nothing, and we can still measure the brain, how it works and how regions connect among each other. And again, we found this pattern where DLD children show increased connectivity between regions, meaning that those regions talk more together. They are more connected, which seems to not be normal, because again, in TD children, they don't have that. So there is something abnormal. And again, we found this age by group interaction suggesting some sort of abnormal developmental trajectory. So everything is, again, for debate, because we're hoping to get a grant to get more subject, because obviously it's a small sample and it may not be robust. But what I'm trying to study and debate and, convince people is that maybe, executive dysfunction is behind the language disorder, and that there is probably an atypical brain development in those children that could be related to an abnormal synaptic pruning. Obviously, it's only a hypothesis, and I hope, to work on that topic later and study more this disorder, because it's an issue, and we don't have a lot of treatment at that stage. It's really just behavioral intervention. There is no medication or anything like that. So we don't know what target we could use in the brain. So that's an issue, and that's kind of what I'm hoping to answer, finding really specific brain regions that are abnormal and specific, or at least sensitive to the disorder we could target for, pharmacological treatment. But right now, most of people just focus on the language part, but it's clear that it's not just that, and that there is more behind this disorder. So yeah, I'm happy to take any question or discussion of, if you have any idea of what could be done, or, another step. I'm happy to listen other people talking.
Really interesting. I'll open it up now to questions.
Hi, Dr. Doucet. I'm Maureen Tierney. I'm the chair of clinical research in public health on the Omaha campus. And I'm particularly interested in your work, not only for its importance in and of itself, but I have a child who's actually falls into this category. And so I apologize for being late. How impaired were your developmental learning disabled children? Like where were they on that spectrum?
So not too impaired. So we excluded any children that had an IQ under 80. So everybody had an IQ above 80 to make sure that it's not just a developmental impairment overall, like a disability. So they are still, going to school and behaving. It's just that their language really had.
This is one clinical / parental observation, but sort of in a way for future use. But a lot of people have observed that folks in this sort of setting have maturing of communication and working memory really in their almost starting in their late 20s, 30s. That there's sort of, and I don't know, could this have something related to synaptic pruning? But it's an intriguing phenomena that the social behavioral aspects seem to improve much later in life than they do for other people. And I'm just making that sort of observation for potential other future endeavors.
Yeah, I mean, and everything, is connected and linked, right? People learn to compensate. So it's maybe they take more time to learn to compensate because I know there is this website, dldandme.org, that is very helpful for people with DLD, and they show example of adults with DLD and their, social issues because they are afraid to talk because they have issues to talk. So that means there are some social rejection, and then they take more time to open and learn, and they typically need therapy and treatment to help them improve that part of their life. And having a job, it's also very challenging in that way, that writing, right, and reading the application. So there are so many consequences, and it's very difficult to distinguish where it's coming from.
Thank you so much for your work and for presenting today.
Yeah.
So I wonder if, is there any heritable component in this, any, genetic predisposition? And also, are there any animal models for, I mean, maybe not for DLD, right? But for like the hyperactive regions of the brain, is there anything in the literature in terms of, diseases or models where you see similar kinds of patterns in an animal model that might suggest or be a way to dig into the causes, or which neurons is that, and how could you address it?
So to answer your first question about the genetics, so I know there have been studies that didn't find any clear gene, so it's still totally unknown on that. So it doesn't seem to be driven by one specific thing. I know also another risk factor is actually the maternal education. So lower maternal education is a higher risk for developing DLD, but there is no clear genetic link so far, at least. And at the animal level, so I'm really not an animal model person. So I really don't know, but I doubt it. But maybe I think the next step is to link it to ADHD, because a lot of children with DLD have ADHD. I don't remember the percentage, but since they are model for ADHD, there may be something to do, but the language part is what people care. And so, yeah, as you said, an animal model for language disorder might be more challenging, but I'm not an expert in that. So I just know behavioral and human some research on that.
So your next step, your grant submission is it NIH grant submission, and what are the aims, or what are your next steps?
Yeah, so I have already submitted once, and so I got reviewed with a 45 percentile, so I'm planning to resubmit. So what I presented to you is almost the grant itself, where it's really focusing on the working memory and the structural brain aspect, the functional one, and we also do spectroscopy actually to measure GABA. And so that's another part of the grant, to try to link that all together to predict, or at least to find what predict or is associated with executive dysfunction. So I'm really hopeful it will be funded next round, but you never know, right? I have good preliminary data, and I think it's supporting my hypothesis. But people are still like, why do you study working memory when you should focus on language? It's, well, working memory is also essential.
It did look like Dr. Andikuri, maybe you had a question, and then we also have one in the chat. Dr. Andikuri, do you have something you'd like to bring up?
I was just typing my question. Thanks for that great presentation. My question was more about English being a second language or bilingual parents, because if the parents' education is a factor that you've observed, could it be because English is not their first language, or
So, yeah, so in our case, we definitely only focus on English as a first language, because of that issue. But I know DLD has been found in several countries, so it's not specific to English, for example. But yeah, most of the time we have to exclude, just because for example, I'm not I speak French, but I don't speak Spanish, and you need a specific English language task that is adapted to the first language, obviously. So right now we're only testing English speaker, but yeah, it could be. I mean, I really don't think it's related to the language I speak, because I went last year to a conference about DLD, and there are actually more and more studies about bilingual children in DLD, but trying to understand even just bilingual, how it works, because it's another question, but it's definitely not related to DLD directly. It might impact it, but not.
So
Thank
you
you.
have several questions, one from Aditi in the chat. How does DLD classify in comparison to autism or dyslexia? They seem related. Do they have overlapping behavioral characteristics?
So yeah, I can answer quickly. So if you have autism, you cannot be classified as DLD. So that's why we have to first exclude children that may be autistic. So we do a test for that. Because there are a lot of overlap. So that's also at the start when children have some issue, right, at school, they have trouble to follow up. So you have to distinguish autism. I know dyslexia is comorbid. There is a high comorbidity with it. I don't know the percentage of overlap, but there is clearly some overlapping behavioral characteristic. And that's why it's a little bit challenging for teacher or for parents to determine which one, and then who they should see. So they really need to go see a speech therapist that can evaluate and differentiate those different aspects to define exactly behavioral specificity for DLD, because DLD and dyslexia is still not, they are not the same. They are still very specific characteristic each, so we can.
Okay, and then Adja Duller.
Yeah, thank you for your presentation. Just another question about other languages. Do you think there could be any kind of interaction between the way someone's first language is processed, like if it's more pictorial or phonetic, between that and then D&D, like something like that?
So I'm not language pathologist or speech therapist, so I may not know. I probably don't know that, unfortunately. I don't think so, because DLD is associated with all different alterations. So it's not just I had like hold on, let me see what. Yeah, it can be all the different part of language structure. So that can be spelling, syntax, grammatical inflection, lexeme, phonemes. All those may be impacted in different level across children too. So yeah, from what I understand, it's not related to their first language.
Okay.
Okay,
And then
thank you.
last question, I think Jack Roush.
Yeah, thanks for the presentation. You showed a graph that said children with DLD often have a reduced amygdala volume. I've read some literature that suggests that having a reduced amygdala volume puts you at increased risk for having febrile seizures. Is that something you've noticed in the cohort of people you've studied?
So we actually exclude anyone that have epilepsy. And I think in our case, we actually found that their amygdala was bigger. It was red, but I forgot that I didn't show the direction of the effect, so I apologize for that. It was actually an age by group interaction. So, but I think they do have, amygdala is very sensitive to disorder, to several disorders, and it's a very unspecific finding in that way that it's impacted by development as well. At that age, they are also in the middle of emotional processing, learning to respond to emotions. So the amygdala is very involved in that. But in that case of epilepsy, typically if they have epilepsy, I think they also cannot really be diagnosed with DLD directly.
All right. Thank you very much, Dr. Doucet. Interesting. Good luck with your upcoming grant submission.
Thank you very much.
It's a tough world. So, Dr. Racette, please share your work with us.
All right. So, can you see?
Yes.
Just slides. Is that what you see?
Yep.
Perfect. And I accomplished my only major responsibility today is getting that working. So I'm a human study also I'm going to describe. So I think I was the closest to basic science today, but definitely very similar to Gaelle's talk in some regards. But a very different kind of study. And I will talk. I can do this talk in an hour, or I can do it in 10 to 15 minutes. I'm just going to do this in 10 to 15 minutes and end with sort of where we're going with this and tell you the outcome of our grant. So I'm going to tell you about what we have very awkwardly, the acronym we've very awkwardly created for our South African manganese environmental neurotoxic toxic effects research study. So this is a study that's been going about 7 years, and it's a manganese, an adult manganese neurotoxicity study based in South Africa. And tell you a little bit about why we care about manganese, and then just sort of tell you about, I won't really touch on the 20 years of research we've done in manganese in welders and other studies in the United States, but this is really this is part of a portfolio of manganese studies that has really occupied the primary focus of our lab for really over 2 decades. So manganese is an interesting neurotoxicant because it's unlike lead. It's actually it is essential for some physiologic pathways in the body. So whereas lead, there may not be a safe level of lead, but there's no need for lead in our bodies. There is actually a need for manganese, but we've evolved to tightly regulate the amount of manganese that's absorbed primarily through the diet. That's how our normal manganese. It's the normal route of entry for manganese into the body, and the GI tract tightly regulates that through excretion through the liver, and so it's like there's about 5% of oral manganese is absorbed across the gut, and then excess manganese is excreted by the liver when it's consumed. So, but when manganese is inhaled, those regulatory mechanisms actually fail, and manganese can accumulate in the brain. And I'll show you. Well, I'll tell you a little bit more about that later because it's an important. Sorry, I get crap popping up on my screen. It's an important part of the story here. So manganese is important because it's critical to the steel industry. It's used to harden steel. And most of my studies until about, well, just about 15 years ago, we were studying primarily welders, manganese exposed welders. And I started because I was interested in whether manganese exposure was a potential risk factor for Parkinson's disease. And we're still trying to answer that question 20 years later, but we're making good progress in this study as sort of part of that portfolio. Manganese has become cooler recently because it's actually a critical component of EV batteries, and it's on the Federal Register as a critical element because it's essential. It's currently under the current battery structure in EVs. It's necessary for battery function. So manganese is actually, there's a couple of manganese mines that are planned in the United States just to create a domestic supply for manganese. One of those actually in the Patagonia Mountains near the border of Mexico. And so there's an uproar in the Patagonia, town of Patagonia, and in Nogales because of this manganese mine. But so common exposures from manganese in our occupational includes welders, smelters, steelworkers, miners. We do have a miners R01, it's active, and sort of the new exposure that'll be of interest going forward is EV battery workers. It's also a common environmental exposure, and it's actually released in just in auto emissions. And so if you look at areas of the U.S. where with high manganese exposures, actually every urban area has some level of manganese exposure just from automobile emissions. But there are other sources, and one part of our lab uses Medicare administrative data to try to understand how those environmental exposures are related to neurodegenerative diseases. And it's a co-exposure in some pesticides as well. So this is basically very much a very high level view of the original smelter study that started about 7 years ago. And so we were about 16 years ago, I started working in South Africa, developing a neuropathology study in the manganese mining industry, and successfully was awarded multiple grants for that, including a couple of federal grants and one R01 that's active. And while we were doing the work in that study, we were contacted by a community that was adjacent to what was at the time the largest manganese smelter in the world, which was at the time it was called the Samancor Manganese Metalloys Plant. And the community was concerned because the plant had been polluting the environment for 50 years, and the air quality was shocking in that area because of this. This is an area. This is actually the next stop after the manganese ore is mined in the Northern Cape region of South Africa. The arrow points on the left to the community we study. This is in Meyerton, South Africa, southeast, about 30 miles southeast of Johannesburg. The second picture is a picture of the smelter at its glory, putting out lots of pollutants. And the community is right across the fence from this. And this is a picture of a daycare immediately on the other side of the fence from this smelter. And then on the right, you see a dispersion model that shows some of the model manganese exposure for the community. We focused our initial study on the health effects in adults in these 3 settlements that are right across the fence from the smelter. And these communities are entirely Black South African, sort of low-cost housing. Just like we do in the United States, low-cost housing gets put right next to industrial areas. And so these are communities that arose sort of initially as a result of apartheid, when Black South Africans were forced out of the city, and then people remained in these areas, but there was inadequate housing during apartheid, and even to date. And so the government has created these low-cost housing communities, but they're adjacent to, in some cases, pretty poor, pretty lousy areas with poor air quality. As I said, at the time, the cement plant was the largest in the world. And we were brought in actually in part by the Department of Environmental Affairs to help assess the health effects. My colleague Jay Turner and his grad student Pradeep Pratibha conducted air PM 2.5 MN measurements at 3 fixed sites over 4 years. Lots of drama occurred with that. It was very, very challenging. But we did it, and then we compared performance on motor, cognitive, and behavioral health outcomes cross-sectionally in 800 exposed and about 100 non-exposed research participants from the region. Our non-exposed community is actually about 30 miles, actually it's more about 50 miles away from this site in an area that where we confirmed with has low manganese exposure, and it's another entirely black settlement that is in a bit of a rural area just on the northwest side of Johannesburg. And as a pilot study, we also performed brain MRIs in 60 research participants to get pilot data for the renewal of the grant. So this is just a slide that shows the efforts that went into the exposure measurements. We did a good job under the circumstances of measuring air pollution, but there were challenges, and we didn't get overlapping for logistical reasons. We had some lack of overlapping measurements at the three fixed sites, and it created some challenges with the dispersion modeling. It still created a dispersion model, but we had personnel challenges that led to some of the missing data that we would have liked to have, but we will rectify in the new grant. And in this slide, showing up on the top, Jill, my colleague Jill Nelson, who is my main collaborator in South Africa, has worked with me for 16 years. And then one of my grad students at the time, Wendy Lamini, who's actually now currently she's from Swaziland, and she did her master's at Wits, but is currently a PhD student at UW in Seattle. So she leveraged her experience working with us to actually make it to the United States and get a PhD. So the primary study results that we published out of this, and we had a dozen publications, but I'm highlighting sort of 3 major publications that looked at the health effects, which was the primary goal of the original grant. We compared the performance on motor, cognitive, and mood assessments in the Meyerton exposed community to the non-exposed community in Ithembeletu. And what was unique about this study as opposed to prior studies is we actually used a clinically relevant measure of Parkinsonism. So I'm a movement disorder specialist, and so I did all assessments in these 900 people in the study, and we were able to demonstrate that the performance on the motor test was poor. In this case, higher scores on this Parkinson's rating scale in Ithembeletu compared to the control community. Poor performance on groove pegboard. They also had poor performance on a battery, a cognitive control battery that include digit span and go no go, and we used the matrix reasoning as a nonverbal IQ test, and they interestingly performed more poorly on that as well. We had a lot of challenges. The community is, there's multiple languages in the community. We validated questionnaires in Zulu, Xhosa, another language I can't remember, and Afrikaans. And so we had a lot of initial work that went into this study just to get the study up and running and create SOPs that just didn't exist for doing this kind of work. And then we also found that mood in particular was worse in Meyerton compared to Ithembeletu. We don't think that that's necessarily causal. It likely is more related to some of the sort of the hopelessness in the community regarding the 50 years of air pollution. But interestingly, current anxiety was also worse course in the participants from Mayerton. So we had a successful 5 years of this grant. We actually, I should also mention the MRI data was provocative but just enough to be useful for preliminary data. So this is a plot of something called the palatal index, which is a measure of the.
So Dr. Racette, I have a question for you.
Please.
So I'm wondering exactly what form of manganese is toxic to human, because you have also mentioned that manganese also have beneficial effect in human, like it's involved in different signaling pathways. So I'm wondering exactly what form is toxic to the human.
I get that from chemists all the time, but the reality is that we measure PM 2.5 Mn, which is every form of manganese that's in that particle size of 2.5 microns or smaller. So the studies in humans that look at the neurotoxic effects of manganese it focused entirely on PM 2.5 Mn or PM 1 Mn. Actually, we're going to be looking at PM 1 Mn in this current study, which is gets into the alveoli and crosses more easily into the bloodstream. But we do not have currently an answer to your question as to which state of manganese is actually the most toxic. It's very likely. I mean, it's very likely that there is there's a difference with different forms, but this came up in a review of a neuropathology paper that we have under review recently, and we just don't have the answer to that.
Okay, thank you, Dr. Racette.
And related to that, so as I mentioned to you, manganese accumulates in the brain. The primary accumulation site is in the globus pallidus in the brain. I'm not just to be sensitive to time, I'm not showing those images now, but it's to date the best biomarker of manganese exposure. So greater exposure in pretty much any setting, whether it's in any occupational setting, you'll see more accumulation of manganese in the globus pallidus. It creates a bright signal in the globus pallidus that we can quantify. And then in this particular pilot study, and this is a pilot study of 60 people in a community study, is actually a pretty large study, but we recognized we needed to go in with shock and awe evidence that we could do this in the community. And we did see a relationship between Parkinsonism, so our primary health outcome in our study, and the pallidal index. It's most compelling as you get higher in terms of exposure, and it's kind of at the sweet spot for preliminary data. It's like, I'd love to see a more robust relationship, but it's perfect preliminary data for an R01 to say, if we have a sample size of 300 or 400 people, then we'll actually be able to really demonstrate this relationship more conclusively. But it's really important because the exposures in this setting are 2 to 3 orders of magnitude below occupational exposures, where we and others have previously demonstrated neurotoxic health effects.
I have not. How's that going?
So is that?
Yeah, thank you, Dr. Racette.
I'm getting okay. We just have unmuted issues there. That's fine. So where are we going with this? Well, so we have an R01 that was reviewed last year, and these are the modified aims for that R01. The initial R01 got a 12th percentile, but that's not fundable under NIEHS's pay line. It's the 10th percentile. So for Gaelle, that's what you're up against, right? Is you have to resubmit a 12th percentile. So the aims were to actually follow the cohort that we developed forward, because we've demonstrated in our manganese studies that we only see dose response relations in when we follow people longitudinally. And so we did not see dose response effects in our cohort, but it was cross-sectional. So in the study, we're following people forward. We're also adding new quantitative assessments of non-motor Parkinsonism, including non-motor symptoms of Parkinson's, smell, and balance testing, more sophisticated balance testing. And then, of course, we're adding brain MRI using, and so our pilot study, we used a community-based MRI scanner, 1.5T. We're going to be taking our research participants to Johannesburg to do multimodal brain MRI, including we're quantifying exposure, of course, using the same methods that we did in our prior study, but also using state-of-the-art DBSI neuroinflammatory measures, because we've demonstrated in other studies that there's inflammation seems to underlie the mechanism of manganese neurotoxicity. And in this, we're using mediation analysis to try to understand causal relationships. And then the final aim is something that we owe the community, is really to develop a dissemination plan. We did a really lousy job of disseminating information to the community, in part because it's a very low educated community, and it's not so simple how you communicate complex information. So our dissemination plan actually involves multiple steps of really understanding the literacy of the community and developing a culturally appropriate message for the community with regard to the results of the study. So this was the revised grant, and so it was reviewed a month ago. We got a 3rd percentile, so that actually will be funded because that's well under the pay line. So we were persistent. And I'm very happy to take any questions. So it's a little different, I guess, very similar kind of presentation to Gaelle's in terms of the, where you've been and where you're going. Fortunately, in this case, we've been pretty successful with the revision.
Really interesting work, really significant. Before, while people get prepared to either put their hands up or throw something in the chat or unmute, I'll say, I believe, and you can tell me if this is true, that you welcome med students or other learners to participate in your own research projects or those of others at the Barrows, I believe. Is that correct?
Yeah, we happily have medical students work with us. I mean, what I don't do is medical tourism. So if somebody's going to work with us on these kinds of studies, they got to be committed to the study. It's not like we're coming in just to see the poor Africans. They need to be engaged in the project. But we do have many students that have worked with us, and several currently working with us, primarily on other studies in the lab. We have dozens of things we're doing. We have quite a lot of funding in the lab across multiple different research domains, and do have students in the lab.
And I would imagine probably the same thing is true at Boys Town, that Gaelle, you're probably open generally to Creighton students or other learners.
Yeah, maybe not this year, but next year I will definitely have more availability. Yeah.
Okay. All right. Questions?
Also, I'm just curious about the MRI scan. How do you collect any functional sequences, or do you plan to do any fun?
Yeah, so
Cool.
we probably will. We actually have functional MRI data on like 500 welders. I mean, we've got a massive amount of data. We've not really published anything out of that, interestingly, and the long story behind that. It has more to do with my prior research environment and some of the challenges with publishing fMRI out of WashU. Of all places where you should be able to publish it, we had some challenges. But that's something, that's a vast amount of data that we've not really done enough with. We're going to have an hour of probably, our goal is to have an MRI protocol that includes about an hour of scan time, and so we should be able to get some fMRI in there. That's not part of the aims, but as you know, anybody, I mean, once you have them in the scanner, it's easy to add another 15 minutes and gather the data. So you're absolutely right. This is what I showed you are the ones that we talked about, and we do mention in the grant that we will also obtain these other variables, but we didn't power the study for this. We didn't measure that, right? And we did all this on a community 1.5T scanner and for feasibility. we're taking it up a notch with the 3T scanner at Nelson Mandela Children's Hospital, where we'll be doing the scans, and so we'll be able to do much more sophisticated work.
Mhm. Yes.
Ajaduma?
Yeah, thank you for that presentation. I saw that even within South Africa, like across the different regions, the type of manganese ore or the quality or the smelting process all can vary significantly. So I was wondering if you think that can moderate the environmental risk that people living in communities around them have.
Maybe. Yeah, I mean, maybe. I think it's actually, this smelter has actually been decommissioned. So now the historical exposures are, well, the legacy exposure of that is all resuspended dust, and the exposure is actually pretty significant. The resuspended dust exposures are, the PM 2.5 MN in the resuspended dust is actually as high as a lot of industrial exposures in the United States. There's another smelter in Durban. I think it's still working, but I mean the manganese comes from the same source. It all comes from the Northern Cape. So I'm surprised that there would be differences unless the techniques are different. There is actually an EV grade battery facility being put in northern South Africa, and those exposures actually definitely will be different, because the process for creating EV grade manganese is not a heating process, it's an acid process. It's like an acid bath. So I'm sure the exposures there will be quite different. But in the Northern Cape, I mean, it is true there's some difference in the mineral content throughout the region, and we've got only some modest amount of data to describe that. So I think there's a lot less known than probably we would like.
Okay, thank you.
Dr. Tierney?
Hi, Brad, thank you so much for that presentation. I think we've all learned a tremendous amount about a new potential cause, et cetera. When you and I got a chance to meet, we had been talking about, this perspective that was Parkinson's more common in Nebraska or not. And I was just wondering, in terms of manganese exposure agriculturally, whether or not that's something that, your agricultural industry is associated with any increased manganese exposure.
Yeah, so the crops that use the manganese containing fungicides are not in Nebraska in the Midwest. They're more, it's more in the north and northwest. But we have, and the industrial sources of manganese are really in the industrial Midwest, Ohio River Valley, Mississippi River Valley area, and of course in the Great Lakes. We have some pretty compelling evidence, new evidence from one of my research scientists that shows, we've done this as a follow-up to another study we did, shows that there is a relationship between Parkinson's disease risk and those environmental point sources in the United States. But we have a whole other area, the part of the lab that focuses on sort of a administrative data version of exposomics, where we look at a variety of different exposure sources, exposure types, everything from pesticides to multiple, there's many hundred neurotoxicants that are in various, EPA and other related data sources. And what we found in your region in Nebraska is we've actually identified 2 or 3 pesticides that are actually used in that region. I don't remember which ones specifically that seem to be associated with PD risk. And that's something that's data that we're just completing right now. And it's going to be very interesting, because we're able to look at subregions of the United States and identify exposures that are specific to that region, which totally makes sense. That paraquat is probably increases risk of PD, but paraquat's not used in every part of the country, so you're not going to see paraquat as a risk factor in Nebraska. You're going to see other pesticides used regionally. So stay tuned, Maureen. I've got some very cool data coming out of Brittany Kurzanowski and team that's going to be getting in the news a lot, because in fact, we have a press release. They had a press release out of the NAN presentation that we're giving next month that describes some of those results.
Looking forward to it. Thank you so much.
Cool. We'll watch for that. Well, we're over time, and thank you both. Really interesting, both really interesting talks. And I think we have some great stuff going on within our larger Creighton community, and a lot of neuroscientists all together. So that was fun to hear. Okay, so April 26th, the next scheduled one, we'll send something out, and enjoy the afternoon and the weekend. And many thanks to both our presenters. It was great
Thanks,
to have.
everyone.
Thank you very
Thanks so
much.
much. Go Jays.
Yeah. Bye-bye.